Hello, this is another particular situation on multiple regression. One more time. Now we have a 4 independent variable, right? There's a 4 slopes and 1 intercept and the dependent variable, right? But in this particular case, can you see that this particular lines are bolded than the other two lines, right? I am interested in both 3 and 4 additional effects above and beyond x1, x2. x1, x2 is what? Controlling variable. I also want evaluating x3 and x2, x4 separately and as aggregated effects above and beyond x1, x2. Are you with me? Combination of x1, x4, like both effects onto y above and beyond x1 and x2. We are using block design carefully to how to get answer out. Again, what is effects of x3 and x4 onto y after control for x1 and x2? That is a research question we like to evaluate. Okay, let's get it. Right, this is SPSS data set file. There's a 1, 2, 3, 4 independent variable and dependent variable, right? Let's try to analyze regression analysis. Of course, we are in the linear regression, right? So let's cleaning up those, residuals, what we did it. Right, dependent variable, go to dependent variable slot. And the first block, and then we are using those two x1, x2 as what? The first block as a controlling thing. And then we enter those control variable first. And then click next. And then we create the second block. In this second block, and then we are adding both x3 and x4. Now we are evaluating not only for the individual effects and for the x3 and x4, we're also evaluating what? What is aggregated, both x3 and x4, additional statistical explainability above and beyond x1 and x2, right? Click OK, and we're able to see this regression analysis result. Again, descriptive statistic, mean, standard deviation, sample size, boring, correlation among x1, x2, x3, x4, and y, similar, right? Similar as before. Okay, let's carefully look into this model and enter variable entered and removed. First model was what? Dependent variable was linear function of x1 and x2 only. Method is enter. Second model is what? What was the second model? Basically, you are not playing around the two independent variable. Your dependent variable is what? x1, x2, and x3, x4. Are you with me? So second model including 4 independent variable. Please, this is kind of confusing. It looks like you only evaluating what? Dependent variable with only 2 independent variable, which is not true. Basically, you're evaluating the dependent variable with all 4 variable, above and beyond the previous model and adding this one. Right, model 1, R square value, again, approximately 31%, approximately 40%, even including 2 independent variable, right? R score change from nothing to 2 independent variable, x1, x2, first model is what? 31% change. It is statistically significant. And then also, you are adding 2 more independent variable in model 2. See, predictors are 4, this B model, right? Second model, you have a 4 independent variable, 2 additional 1. R score change was what? 0.088, nearly 9%. Well, that is also what? Statistically significant. This is smaller than 0.01, which is conventionally the smallest alpha value. So you will say what? Well, both combined x3 and x4 statistical explainability, additional statistical explainability is also what? Statistically significant. One more time. Those 3 and 4 additional statistical explainability or R squared change above and beyond x1 and x2 happen to be statistically significant, which is great. If you just want to evaluate whether the second model is statistically significant or not, you have to consult this value, not this value. This value tells you what? All 4 independent variables. The second regression model is statistically significant. This p-value is what? Focus on what? Additional 2 independent variable above and beyond x1, x2 is a statistically significant or not. Right? Coefficient, same thing. The first model, you have a 2 independent variable, 2 slope, and each slope statistical significance. Second model, you adding 2 additional x3 and x4, right? And then you're able to see what? Each x3 and x4 statistical significance in here, and the slope value itself. Again, these 2 slope for the x1, x2 is different from this second model slope value, right? Not only slope value of x1, x2, the statistical significance is also different for x1 and x2, right? And how to interpret this x3? Well, this x3 slope value is this 0.217. It is statistically significant in 0.01 alpha value is less than 0.01, right? After control for the other independent variable, i.e. x1, x2, x4. Right, how to interpret this x4 effects? Slope is 0.015. It's not statistically significant after control for x1, x2, x3. See, like whatever the other independent variable, right? And this is a statistical significance after control for the other independent variable. This is how you're interpreting those each individual effects. Again, what important thing? This particular role tells you what? What is x3 and x4 additional R-square, additional statistical explainability is a statistically significant or not. It is statistically significant by combining both 3 and 4, right? x3 and x4. But this statistical significance is what? All x1, 2, 3, 4 are statistically significant or not. And this is how you evaluate in all x1, 2, 3, and 4. Okay, good. This is time to stop this video.